Hey guys, welcome back. Today we're going to work on 1.5, which is analyzing graphs of functions. You can see all the learning targets here. Essentially what we're doing is key features of graphs that you guys started back in Math 1 and then built on the last couple years. And today we're going to add a couple pieces. So I decided to do these notes in two different chunks. So there's going to be two screencasts. Each of them will probably be between 10 and 15 minutes. Okay, so this one is only going to cover the majority of the first page of the notes. So we're going to go through and do the key features for this example, this warm-up, and then I'll talk about relative minimum and maximum, which is a new topic for us, and then I will talk about this interval of constant, which is new, and then the other notes will get into really detailed stuff on even and odd functions, which I believe you were exposed to, but we'll get a little deeper than what you did last year in Math 3. Okay, so this video is if you need a refresher on simply key features. If you're good, you can fast forward until I start talking about relative min, and then of course everyone needs to watch that second video if you're not live with me. Okay, so for this graph, the domain, again, is our x values, right? So we work from left to right. We list everything here is going to be interval notation. So for my x values, my lowest x value is all the way to the left. My highest x value is all the way to the right. And of course, this is going to keep going to the right, so it'll go to infinity. So this will be -5 to infinity. Range is our y value, so our lowest point on the graph looks like this here. Don't be fooled, that's not the highest point because this is going to go forever. So this will be from, what's that, -3 up to positive infinity. If I hear any jokes about my infinity signs, I'm going to be a little upset. I'm not an artiste. Okay, X-intercepts, looks like we have 3 of them. So I'll just separate them by a comma. So -3, 0. Please list the coordinates, not just the x value. 3, 0, and 5, 0. So you can have multiple, right? Most of the times you will. Y-intercept, you can only have one if it is a function, right? Because if you have more than one, that would fail the vertical line test. So Y-intercept at 0, 1. Okay, intervals of, this applies to, what was that? Come on, Larson. I think you've been here before. What happened? I struggle with anything that's like, that I consider that art right there. Like, who's good at these? That's not bad. Okay. All right, I'm going to do constant last because that's a new piece. Intervals of increasing. So increasing, of course, is sloping upwards. So we have this section here. We have this here. We have 3 sections. Okay, so we kind of look for these corridors, right? So between x values of -5 and -2, we use a union symbol here. Let's see, this is between x values of 0 and 2. And then this last one is from 4 and it just goes forever, right? 4 to infinity. Looks like I'll be increasing that entire time. Okay, decreasing, we use red for that, right? Like any financial people out there, red is bad when you're talking finance. Decreasing, so that is from, looks like 2 to 4. Okay, constant. This should not be earth-shattering for you. It is the flat section, okay? This is our interval of constant, so in that corridor. So from -2 to 0. And if you put all those together, you're basically getting your domain, right? If you kind of just move from left to right, you're representing the entire domain. Everything's either increasing, decreasing, or constant. Okay, positive and negative. In other words, above the x-axis, below the x-axis. So above the x-axis, there's two sections, right? This first one goes from -3 to +3. The second one goes from 5 to infinity. Negative would be this section here and this section here. So we have -5 to -3 and 3 to 5. Okay, let's skip over relative minimum and maximum. And let's talk about absolute minimum and maximum. You guys know this. You may not realize it, but I think your math teachers probably just called it min and max instead of absolute min and absolute max. So your absolute minimum is the lowest point on the graph, the lowest single point on the graph. Not every graph has an absolute lowest point. This one does. It's right here. So the absolute minimum is -3, the y value, okay? The absolute maximum is the highest point, and because this goes forever, there isn't a single point where I could point to where I'm like, okay, that's the highest point, because you could just go a little bit higher, and then somebody else could go a little bit higher, okay, and you could do that forever. So there is no absolute maximum. Okay, so this is going to bring us to a new topic called relative minimum and maximum. So first I'm going to talk about my relative minimum. So relative minimum visually is going to look like one of two things. It's going to look like a U or a V, okay? And this point at the bottom is going to represent your relative minimum. And what we need to make sure that we realize here is that we need to switch from decreasing, then we hit that minimum, and then we switch to increasing. Same thing here. We go from decreasing, we hit that minimum, and then we go to increasing. If that's your scenario, then you have a relative minimum. Okay, so for a relative min, you must switch from decreasing to increasing. It can't be from decreasing to constant. It's got to be from decreasing to increasing. Okay, now let's talk about a relative maximum. You can imagine the same thing, right? It's just going to be flipped. So like the top of a hill or the top of a mountain. Okay, so those values there are your relative maximum values. Same thing, you need to switch from, now it's the opposite. It's increasing, then we hit that maximum, then it goes to decreasing. Increasing, hit that maximum, then goes to decreasing. Okay, so for relative max, I need to switch from increasing to decreasing. So let's look at our graph. What do we have here? Let's see, minimum I did in red. This point here looks like a V, right? I go from decreasing to increasing. So that is a relative min. How about this point over here? I would say no, because by definition I must go from decreasing to increasing, and I'm missing this decreasing section before that point. So that is not the That is not a relative minimum. You could have an infinite number of relative minimum values. Okay, you can only have one absolute minimum, but you could have infinite number of relative minimum. You could also have the same point be a relative min and an absolute min. Like if this section did not exist, this point right here would be a relative and an absolute min. So that's possible. Okay, relative max, this guy right here. So relative, let's do the max first. So max is at a y value of 3, and relative minimum at a y value of -2. This has no symmetry. Okay, I can't flip it over the x-axis, y-axis. It doesn't have around the origin where we spin it. Like we put a pin in the origin and spin. That doesn't work. We'll talk more about that when we get to odd functions. And then f of -2, go over to -2, go up or down till you hit your curve. My output would be 1. F of 2, go over to an x value of 2, go up until you hit your curve. That would be an output of 3. All right, so that's your 11-minute and 23-second recap, give or take, of key features. Okay, last thing in this section I'll cover is just X-intercepts, Y-intercepts. You guys know that, right? X-intercepts, also known as zeros, solutions, roots. It's the point, it's the ordered pair, x comma y, where the graph intersects with the x-axis. You can find it by plugging in 0 for y. And the y-intercept is the point, the x comma y ordered pair, where the graph intersects the x-axis. Plug 0 in for x. Okay, so if you guys could check back for the other, we'll call it half, the other half of the notes, that'd be awesome. That is in video number 2, even and odd. Thanks, guys.